3.5. We are talking about rational roots. Theorems. There are several we are going to discuss today. First of all, though, we have to understand what that all means, right? When we say roots, roots are the foundation of your polynomials. Your roots are your solutions. They are your zeros, right? They all mean the same thing. They are your answers. They are where the polynomial crosses the x-axis. Right? Those are your roots. That's what makes up your polynomial, right? When we say the word rational, we had the word rational, a reminder of it at the beginning of the school year. A rational number is any number that can be written as a fraction. All right, so the first theorem we're going to work with is finding all your solutions that are rational numbers, okay? So the rational root theorem, that's what we're starting with. Rational roots theorem works like this. You have a polynomial, whatever that polynomial may be. So I'm going to say ax to the n plus bx to the n minus 1. Those represent exponents. So on all the way down to you have a constant or a number at the end, right? You agree that that goes all the way set equal to 0? That is how our polynomials are all written. All right. That being said, to find your rational roots, you are going to take all factors of your final number, your constant, all factors of the constant, and you're going to divide by all factors of the leading coefficient, in this case a, right? All right. Once you get those factors, however many there are, to determine if the factor is a root, plug in and equal, or plug in and hope it equals 0. If not, then it's not a root. It doesn't, right? It would have a remainder. Okay? So here's how this is going to work. We're going to start very, very easy to begin with. First, I want to know, example number 1. Find all possible rational roots. All right? So we're not going to plug them in yet. We just want to find the possible ones. This is up here. Oh, plug in and hope it equals 0. Yep. All right. So to find all possible ones, if our polynomial, let's say, looks like this. 4x to the third plus 7x squared minus 5x minus 3. Let's start with 3. Equals 0. All right. To find your possible rational roots, you take all factors of 3. Well, what are the factors that make up 3? 3 and 1. So we have 1 and 3, right? And we're going to divide those numbers by all the factors of 4. So you have 1, 2, and 4, right? So now we're going to list all our possible. We start with the 1 on top, and that 1 has to be divided by all 3 of the bottom numbers. So 1 divided by 1 is 1, and we're going to say plus and minus because it can also be its opposite. Then we have 1 over 2, or plus and minus 1/2. Then we have 1 over 4, or plus and minus 1/4. Then we go to the 3. 3 over 1, or plus and minus 3. 3 over 2, or plus and minus 3 halves. And then 3 over 4, plus and minus 3 over 4. Those are your possible rational roots. All right? The next step from here would be to take these 2, 4, 6, 8, 10, 12 numbers and plug them into the polynomial and find out which one makes 0. Oh, no. You could get up to whatever your highest exponent is. Could get up to that. So we're not going to do that this time. Let's do the next one. All right? Here we go. Example number 2. We doing okay? Yep. All right. Example number 2. This is exactly what you have to do for problems 10 through 16. The directions say use the rational roots theorem to first list all possible roots, then find actual rational roots. All right? Okay. Here we go. We're going to start off kind of easy. I hope. Let's say I have 3x to the third minus 4x squared minus 1x plus 4 equals 0. Okay? So first we start by finding all our possible. So we take the last number, all the factors of 4, which are 1, 2, and 4. And we divide by all the factors of the first number, which is 3, which is 1 and 3. Are we clear on that part? Okay. So now we have to list all the possible. So right here, we go 1 over 1, or plus and minus 1. 1 over 3, plus and minus 1/3. Then we go to 2, 2 over 1. And 2 over 3, 2/3. Then we go to 4, 4 over 1. And 4 over 3. Let me get this out of my way so I can write that down. All right. So that's the first part of the problem. The next part of the problem is that we are going to plug each one of these into our polynomial to find out which ones work. All right? So we're going to start here with 3 times, let's start with the positive, 1 to the third, minus 4 times 1 squared, minus 1 times 1 plus 4. We're going to plug that in. I got a 2, so this would be no. Correct. So now we go to negative 1. 3 times negative 1 to the third, minus 4 times negative 1 squared, minus 1 times negative 1 plus 4. So we get negative 3 minus 4 is negative 7, plus 1 is negative 6, plus 4 is negative 2. This is also a no. So then you go to the next one, positive 1/3. We're going to go 3 times 1/3 to the third. Minus 4 times 1/3 squared. Minus 1 times 1/3 plus 4. You're going to find that one. Then you go to 3 times negative 1/3 to the third. Minus 4 times negative 1/3 squared. Minus 1 times negative 1/3 plus 4. Then we go to the 2's. So we plug in 2 and negative 2. Whoops, I went too far. Sorry, guys. Okay, so I would have 3 times 2 to the third. Minus 4 times 2 squared. Minus 1 times 2 plus 4. Then I would do negative 2. 3 times negative 2 to the third. Minus 4 times negative 2 squared. Minus 1 times negative 2 plus 4. All right, so here's what we're going to do. Irene, you do 1/3. Alba, do negative 1/3. Dave, do 2. Chris, do negative 2. We still have 2/3. Let's go. Lucas, do 2/3. That one. Okay. Jake, do negative 2/3. Let's see. Brooke, you want positive 4? Do you want negative 4? Do you want 4/3? Positive 4/3? Which one of you two wants to fight over negative 4/3? All right, go for it, TJ. All right. So you each plug in yours and tell me. Okay. Yep, you got negative 4/3. It's not, so this is no? Yeah, I agree. Alba, what'd you get? It's a no. All right. Keep going. I'm sorry, what? No, I said 4. No, I just said, I think, because I gave, let's go back up here, let me do it. So I gave you 2 and you negative 2, right? I gave you 2/3, so I gave you negative 2/3. Okay? Brooke, positive 4 is a no. Guys, hey, positive 2 was a no. What else we got? No? No? All right. So here, I'll make life simple. After you go through them all, this one has no rational roots. Okay? Yeah, so they were all no. So that's the first 4 problems on what you have to do. Do we need to go through another example, or are we good? Okay. All right. Yeah. So now, those were all, we've been talking about rational roots, right? The next thing I want to talk about is irrational and imaginary. So, if I have an irrational root, or an imaginary root, when you have one of them, you actually have 2 of them. So what I mean by that is, if I had the square root of 2, that also means I have to have the negative square root of 2, right? So if you have positive square root of 2, you always have the opposite of that as well. All right? If you are doing an imaginary number, or you have an imaginary root, that also means, so let's say I have 3i, that also means I have a negative 3i, right? If I have, let's combine them together. Let's say, well actually let's do this. Let's say I have negative square root 7. That also means I have a positive square root 7, right? If I had negative 5i, I would also have a positive 5i. And if I put them together, let's say I had 4 plus 2i, I would also have 4 minus 2i. All right? So when you have those irrational and those imaginary numbers, you have the opposite as well. So for example number 3, 4 problems, 8 and 20, or no, 18 and 20, sorry, 18 and 20. The directions state this: find the additional roots. All right, so I'm going to give you 3i and 4 minus square root 2. So your additional roots, what's your additional root for this one? Negative 3i, right? And what's our additional root for 4 minus square root 2? Nope, the 4 is going to stay the same. The only thing that changes, 4 plus square root 2. Okay? So those 2 problems, that's all you have to do is write down the additional roots. That's it. All right? Are we clear on those 2? Correct. Okay? So we're clear for those 2. We're good? All right, let's talk about the last section then. Example number 4. Take a deep breath, because we've got this. Example number 4 covers the rest of what we're doing today, which is problems 22 through 28. Write a polynomial for the given roots. And if I give you the roots 5i and square root 5. If I give you 5i, that also means you have negative 5i. So this is plus and minus. If I give you the square root of 5, that also means you have negative square root 5. Now, these are your roots that we're going to write in a polynomial, which means first thing we do is write them as a factor. So, what is the factor that has a positive 5i? That is x minus 5i. What is the factor that has a negative 5i? X plus 5i. Over here, if I have a positive square root 5, that means I have an x minus square root 5. And if I have a root of negative square root 5, that is x plus square root 5. Now we get to put these all together in one beautiful, fabulous polynomial. Yes. So we're going to do a box for the first 2, and your i's should all drop out. You're going to do a box for the last 2, and all your radicals should drop out. And then you multiply those 2 together. Okay? So here we go. Jacob, you with us? So excited about this? X minus 5i times x plus 5i. X times x is x squared. X times negative 5i is negative 5ix. X times 5i is 5ix. Negative 5i times positive 5i is negative 25i squared. So that cancels and makes it a positive 25. And the diagonal will cancel. So our first polynomial is x squared plus 25. Let's do the next one. All right, we have x minus square root 5 times x plus square root 5. X squared, negative x square root 5, positive x square root 5. And what's negative square root 5 times positive square root 5? Close. How about negative 5? Right? Because you have your negative here, and then square root times square root, they cancel. Okay. And again, what do you notice about this diagonal? It cancels. So this one is x squared minus 5. Now we get to multiply both of those together. All right, so here we go. I'm taking x squared plus 25 times x squared minus 5. X squared times x squared is x to the 4th. X squared times 25 is 25x squared. X squared times negative 5 is negative 5x squared. And 25 times negative 5 is negative 125. So we get x to the 4th. Adding your diagonals together, we get plus 20x squared minus 125 is our polynomial. Now, here's the one thing I want to point out. How many roots did we start with? We started with 4, right? Because you had to have the positive and negative. What's our highest exponent? It's 4. They go together, right? Yep, they will always do that. Yep. All right, how are we doing? Good? Can I do one more example and then I'm done? One more polynomial? Sounds fabulous. Typical, yes. Similar. All right, so here's example number 5. Find the polynomial for the root x equals 1 plus 7i. All right. So if I have 1 plus 7i, I have 1 minus 7i. Now, how these go in the root is a little tricky. That's why I wanted to do one. This is what it's equal to, right? So this should be x minus, and I'm going to put this whole number in parentheses, 1 plus 7i. The second one I'm going to do is x minus, again in parentheses, 1 minus 7i. The reason I did that is because I want you to distribute the negative through, and see, that's why it goes in that way, right? So our first one is going to be x minus 1 minus 7i, and we're going to times that by x minus 1 plus 7i. And, of course, I'm going to put it in the box. So here we go. X minus 1 minus 7i times by x minus 1 plus 7i. Let me fix that. I know it's a little sloppy. I'm sorry. Here we go. All right, so x times x is x squared. X times negative 1 is negative x. X times negative 7i is negative 7ix. Next row. X times negative 1 is negative 1x. Negative 1 times negative 1 is 1. Negative 1 times negative 7i is positive 7i. X times 7i is 7ix. Negative 1 times 7i is negative 7i. And negative 7i times positive 7i is negative 49i squared. So the first thing, you're right, we're going to start here, cancel that, and make that positive. Now, right, so you'll notice this diagonal. We have negative 7i and positive 7i. Those cancel. Our middle diagonal, we have a negative 7ix and a positive 7ix on the outsides. Those cancel. Okay? So you'll notice every single one of these that are like this diagonal adds together, and this diagonal, because it's special, goes this way. So our final trinomial would be x squared. Negative 1x and negative 1x is negative 2x plus 1 and 49 is 50. So if we were to take that polynomial and do the quadratic formula, we would be back to the answers 1 plus and minus 7i. All right? That's where that comes from. Question. Exactly. Exactly. That's the whole idea. Is we need to be able to go backward and forward before section 5-6. Okay? All right. So, we got this. This stuff makes sense? Oh, that makes me excited.